In example 5, we need to write the equation that represents the graph below. So this is a little bit different than the other examples we've done. With the other examples, we were given an equation and asked to graph it. Now we're just going backwards. What I like to do with these is I like to look at my parent function first. So the parent function for this is going to be y is equal to x squared. Then I start thinking about a few different things. I start to think to myself about which way it opens or faces. Is there going to be a reflection or not? This one won't have a reflection, so there's going to be no reflection. And I also like to think about whether it has a stretch or a shrink, or whether it narrows or widens. So the parent function here would start at 0, 0. If we consider this the vertex, the new 0, 0, we would go right 1, up 1, and we would go right 2, up 4. And that's normal for this parent function as well. If you graph that parent function, you would go right 1, up 1, right 2, up 4. There isn't any stretch or shrink or widen or narrow for this one. If you had a point maybe right here, and this point was right here, if it looked a little bit wider, then it would be widened out. It would be widened out by a factor of 1/2. Also, if this point was here, then you'd be going right 1, up 2, and that would be narrow by a factor of 2. This point also would be way the heck up here, 8 units above. So this one, compared to the parent function, has no stretch or shrink. Let's look at the position of the vertex. The parent function the vertex would be here, and so to get to this new vertex, we need to go right 2. So there is a shift right by 2, or this direction by 2, and also down by 4. The vertex with the parent function would be at 0, 0, and now it's here. I like to look at the vertex, and you can look at any point if you want, but the vertex is kind of nice to use for this because it's already at 0, 0 for the parent function. So then this is going to be down by 4. As we piece together this function, we're going to go from the parent function to this new one. So there's no reflection and no shrink, so we're going to keep the 1 out here in front. I am going to use a set of parentheses because I do know that I have a shift right by 2. Remember, we want to write that negative sign here if we're going right, and then it's right by 2. The x direction, the shift in the x direction, that goes right by the x. Outside, away from the parentheses, that's where the y direction or up or down shift is going to go. So this is down by 4, which is negative 4. We want to keep whatever sign that is, so down would be negative. Unlike the x, which we need to do the opposite, so even though it's in the positive direction, you'll see that here as a negative sign. So this is the accurate equation for this graph, and you could do some test points if you wanted to just to verify that's fine, but I think we're on the right track here.